All right, in questions 17 through 18, we are finding the values of the variables. So in number 17, well, both of these actually, we have isosceles triangles. And so remember when we have isosceles triangles, they have two congruent sides, and two congruent angles. So when I start number 17, this linear pair jumps out at me. I've got to do 180 minus 125 to find the value of x. If I borrow from my 8 or just use a calculator, 10 minus 5 is 5, 7 minus 2 is 5. So x has got to be 55 degrees. All right, then if I look at my triangle as isosceles, if I look at which two sides are congruent, the base angles that are opposite those two sides are congruent. Sorry, I know my picture is getting really cluttered. So these angles at the bottom are congruent. So if this is 55, this is also 55. So I don't really have to do any more math. If this angle makes a linear pair with z, I know that z has to be 125 because I already subtracted 125 from 180. So lastly, to find angle y, well, I have two angles that are 55 degrees already, and I could just add that up and subtract that from 180 since the two 55s and the y have to add up to 180. So 55 plus 55 is what? 110. 180 minus 110 should leave us with 70 degrees. So angle y is 70 degrees. All right, number 8, a similar question. This time we're given the lengths of the sides. I know these are sides because these expressions aren't written in the angles. So if I have an isosceles triangle and the two sides are congruent, are the expressions that I'm given, I just have to solve this for x. If I subtract 2x from both sides, I would do it this way. I realize we get a negative x when we do that, but we get negative x equals negative 6. Well, I could think of dividing off a coefficient of negative 1, and I'm going to get x equals positive 6 for that. All right, 19 through 20, we're finding the perimeter. And these are probably not our favorites because we've got to do the Pythagorean theorem. And number 19, if I could count this side, so 3, 4, 5. So one of my sides is 5 units. I'm going to have to do the Pythagorean theorem or the distance formula to find the other two. I'm going to make a little right triangle here. It is 2 by 1, 2, 3, 4, 5. So for that little right triangle, I might resketch it somewhere off to the side. I'm going to call it 2, 5, and I'm going to call that hypotenuse C. I'm going to have to do 2 squared plus 5 squared is C squared. That's 4 plus 25 is C squared. So I get 29 is C squared. So I'm going to say that that's equal to the square root of 29. And I'm actually going to put that in my calculator as the square root of 29. If you don't have a graphing, it might be easier to take the square root first. All right, then I come over to this triangle. This one I might just do on the graph since I'm running out of space. But 1, 2, 3, 4, 5. So one of my sides is still 5. And this time it's 1, 2, 3, 4, 5, 6, 7. So if I counted correctly, let me see, we're going from 2 to negative 5. Yeah, so it's 7. So when I plug that in the Pythagorean theorem, I'm looking for the hypotenuse again. So 5 squared plus 7 squared is C squared. 5 squared is 25. 7 squared is 49. So when I add those together, I get, what, 74? All right, so to find the perimeter, just going back to the perimeter of any shape, it just means to add up all the sides, the sum of all the sides. Since it's a triangle, I know it has 3 sides. And if I use my calculator for these, sorry, I'm trying to pull up my calculator. The square root of 29, you can just plug that into your graphing calculator. Let's see, that should be approximately 5.385. So I'm going to add 5 plus 5.385, and then I'm going to add that to the square root of 74, which is approximately 8.602. All right, so when I add those three numbers together, 8.602 plus the square root of 29 plus 5, I should get the perimeter is, the perimeter is approximately 18.987. All right, moving along to number 20. Gosh, we're basically doing the same thing here. I can count this side since I have a nice horizontal. That's 4 units. And I got to do the Pythagorean theorem on the other two. I know it's not our favorite thing. All right, 1, 2, 3, 4, 5, 6, 7 by 1. So if I pull off this little triangle here, one leg is 1, one leg is 7. I'm going to do 1 squared plus 7 squared is c squared. 1 squared is 1, 7 squared is 49. So I'm taking the square root of 50 to get c. All right, square root of 50. And that's going to be this side right here. To find the other side, I need another right triangle. This time it's got a leg of 3 and another leg of 7. So if I kind of re-sketch this out here, feel free to use more space than what's on this paper. It's not a lot. I'm going to do 3 squared plus 7 squared equals my hypotenuse c squared. That's 9 plus 49. So that one should be the square root of 58. So the square root of 58 equals c. So again, when you're adding these in your calculator, one side is 4. One side is the square root of 50. Oops. One side is the square root of 58. That was a 4. If you've got the graphing, it helps, I think, to just type them in like that. All right, the square root of 50 is about 7.071. I'm going to add the square root of 58 to that, which is about 7.616. That's 14 and some change, and then I'm going to add 4 to that, the third side, the easy side. So the perimeter is approximately 18.687 units. All right. Questions 21 through 22, calculate the area. Fortunately for us, these problems are easier. If I take a look, I could use my formula base times height divided by 2, or I could think of that as 1/2 base times height. So if I do base times height divided by 2, my base could be any side of the triangle. So if it has a horizontal or vertical side and it's on a graph, I want to grab that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So my base is 9. My height is 1, 2, 3, 4, 5. If my base is 9 and my height is 5, I'm just going to do 9 times 5 divided by 2. And that is what? 45 divided by 2. So our area is 45 halves, or I could think of that as equal to what? 22.5 units squared. All right, coming on over to number 22. If I count, if I'm looking at my base down here, 1, 2, 3, 4, 5, 6, 7, 8. My base is a nice 8. My height, I've got to drop an altitude straight down. My height is 1, 2, 3, 4, 5, 6, 7. And my area is my base times my height divided by 2. So that is the same as 4 times 7, which is 28. So 28 units squared. All right, I'm going to do these last 4 problems rather, in a separate video just so this one isn't too long. I'll see you on the next one.